All right, guys, so let's look at graphing transformations of the exponential molar function. So again, this is our standard form. H and K are our shifts. If A is negative, that's reflection over the x-axis. Whatever A is, it's either stretch or compression. So let's just get into it. So here we go. This is the first one. B is 2. That makes it a growth equation. So let's write down our basic points for this molar function. 0, 1, 1, 2, -1, a half. All right, so we got all that. Let's plot them. So I'm going to start with my asymptote. Let me make it dotted. Okay, so I got 0, 1, 1, 2, -1, a half. These are my basic points, but now I need to transform them just like we did in the past. So do we have any reflections? Nope. Stretches and compressions? Nope. Shifts? Yep. All these guys are going to go left 5 units. So 1, 2, if I can count, 3, 4, 5. And about like that. So now we're going to graph this thing. And again, just the 3 points and make it look about right. Does not need to be perfect here, guys. So it's going to get closer and closer to that asymptote as it gets smaller. And it's going to do something about like that. So that is the sketch of this transformation. All right, I'm back. So we got our basic points and we shifted them left 5 units. Now let's talk about all this stuff. One second. All right, here we go again. Let's see. So talking about all this stuff, domain and range, they haven't changed. Oops. Let me go back and copy it. So some of this is going to change. Let's see what changes. Domain and range, those are the same. Okay. As x goes to infinity, y goes to, well, this is a growth equation, so that's going to go to infinity. That doesn't change. As x goes to negative infinity, well, it looks like y is going to 0 still. That hasn't changed. Our y-intercept, 0, 1. Now 0, 1 moved left 5 units, so that is not my y-intercept anymore. Okay, my y-intercept is way up here somewhere. How do I figure out what my y-intercept is? Let x be 0. So if I plug in 0 for x, let's see what happens. I get 2 to the 5th power, which of course is 32. So my y-intercept is 0, 32. Asymptote, well, let's see, it's still right there on my x-axis. It hasn't changed. So for this particular transformation, the only thing that we changed really was our y-intercept. Everything else remained the same. Let's look at the next one. All right, first thing, let's identify what B is. It's a third. That makes this a decay problem. All right. Do I have any reflections? No. Stretches? No. I've got a shift. That's going to go down 1. So whenever I get everything, I got to go down 1, up to 1. Wow, 2. Down 2. That's the number 2 if you didn't know that. Basic points. 0, 1, 1, and B, which is a third. -1, and reciprocate B, 3 over 1, which is 3. Let's plot stuff, starting with my asymptote. All right, let's go ahead and make that dotted. There we go. I'm gonna go ahead and plot my basic points. 0, 1, 1, a third, -1, 3. So if you remember, looking at this, 1/3, that's the reciprocal of 3. So this should be a reflection of 3 to the x over the y-axis. But we can just point plot it. If you want, you can plug in more points to get a more accurate view of it, but you don't need to. Again, as long as you have the basic shape, we're good. Now, what do I need to do with this? I need to shift it down too. Now, on the previous one, if I were to shift my asymptote to the left, nothing happens. See, nothing's happening. It's still staying there because it goes on forever. But if I were to shift my asymptote down, it actually changes, right? So I do need to shift my asymptote down, along with all my other points, down 2 units. So I'm just actually going to grab this and bring them down 2 units. 1, 2. Now, that should be right there. Now my asymptote is at -2. Of course, you can't actually drag and drop on your paper, so let's see how we could do this on paper. You could plot these points down to, let's change colors. It was blue, let's make it red. Down 2, down 2, down 2, so something like that. And then my asymptote, I need to change that. Let's make it blue. A lovely blue color. Make it dotted. And now I ignore this red asymptote and these blue dots, and I sketch my curve. Let's see what happens. And it should get steeper faster, so something like that. I think I didn't go steep enough, but you know what? That's okay. All right. So that is the sketch. Doesn't need to be nearly perfect. Let's see what changes on this one. Domain, that stays the same. Range, that doesn't stay the same, does it? What's my lowest y value now? Almost -2. So we're going to put -2 right here. So my vertical shift will change my range. Does it change my end behavior? Let's see. As I go to infinity, I approach 0. No, not 0, -2. What about as x gets really small, infinity? Yeah, that's the same. My y-intercept, well, yeah, that changed. It moved down. Instead of at 1, it's now -1. My asymptote, well, yeah, we shifted it down, so that changes. So if you notice, the range, what the end behavior approaches, and what our asymptote are all very much related. In fact, they're going to be the same. Whatever our vertical shift is, will be controlling our range and the end behavior and the asymptote. Doesn't matter if we stretch it, doesn't matter if we compress it, doesn't matter if we reflect it. Well, for the range, yeah, it would matter if we reflected it because that would, instead of being our lowest value, would be our highest value. But it's going to be the same numbers in here. This one could either be here at the lower bound or at the upper bound. Let's see what else we got. Ah, there's negative, okay. Let's check this one out. Let's see what's going on. B is 3, makes a growth equation. 0, 1, 1, 3, then negative 1, 1/3. I'm not worrying about anything but my basic points at first. Then I'm going to say, okay, what do I need to do to this? I have this half here. That's a vertical compression. This +1 over here, that's a vertical shift up 2. I'm not able to read right now. That's a 1. All right, so let's do it. Starting with my asymptote right here on my x-axis. Now, you can go ahead and take a shortcut since you're on paper and you can't actually move stuff around. Oops. What controls our asymptote? Our vertical shift, right? That's going to move it up 1, so my asymptote is actually going to be at a positive 1. So I'm going to go ahead and just stick it there. That way, you won't have to erase one dotted line or have two asymptotes and one of them not actually be there. So just go ahead and start by shifting your asymptote. Makes it a little easier. Now my basic points, I will plot and then transform. I've got 0, 1, 1, 3, negative 1, 1/3. Now remember, we multiply before we add and subtract, so we got to do this compression first. So we multiply the y values by a half. This is going to be kind of nasty. Half of 1/3 is a 6, so yeah, it's not really noticeably different, but it's there, it's lower. Half of 1 is a half. Half of 3 is 1/2. Now, it might be easier for you if you go to another place out. We had 9. If we plug in 2 here, we'd get 9 to the original. Then half of 9 would be 4.5. But again, as long as you have the right shape, it's okay. Oops, let me make that red. So if I were to plug in 2 into 3 squared, or 3 to the x, that'd be 3 squared, which is 9. And then half of 9 is 4.5. So if it's difficult for you to get the shape out of the basic points, you can always go up a point or 2 more, whatever you need to do. All right, now I need to shift all of these points up 1. So let's see. I'm going to do a nice, how about black? So this one's got to be almost touching the asymptote. It's right there. I don't want to put it on the asymptote, so let me just do that. It should be lower, but yeah, it's a dot. That should be at a half. That should be at 1.5 plus 1 is 2.5. So right there. And then this dot over here will go up 1 unit to 5.5. So let me sketch that. Let's see, what's a good color? How about this pinky color? And it's not going to be on the asymptote, so let's do that. Something to that effect. Like, doesn't need to be perfect. So this will have a lot of dots being manipulated. Just try and do the best you can with it. I'm not going to be too concerned about the exact location. I mean, this should be a 6, but how are you going to plot a 6 very accurately? You're not. It's okay. Let's see about this stuff over here. Domain, that's good. All real numbers. That's not changing for us. Range, I'm going to get closer and closer, not to 0, but to 1. That changed. End behavior, Instead of approaching 0, as x gets really big, I'm approaching infinity. As x gets really small, I'm approaching 1. So our end behavior changed. Our intercepts, I'm not at 0, 1 anymore. Let me just erase it. I went up, right? Went half of the way, and then I went up 1, so that's at 1.5. So 0, 1.5, or 3/2 if you prefer. Yeah, 1.5, sorry. Then our asymptote, y equals 1. Done. So I'm only gonna have a couple of graphing problems on your quiz Friday. Not that worried about it. I'm more interested in you solving them. So let's just get through these. All right. B is 3/2. Makes it a growth. 3/2 is 1.5. It's bigger than 1. 0, 1, 1, 3/2, -1, 2/3. It's closer to 1, so it should be flatter than the others. And then what am I going to do to it? I got no reflections. I got no compressions. I got to go right 4, down 5. All right. So all I'm having is a shift. And again, the vertical shift will control my asymptote. So let's try this. If you want to, you can manipulate these points right now. Instead of actually graphing them and then moving them, you can just, since it's only shifting, I guess you could do it to anything. We could figure out the values here. We multiply the y values by 1/2 and then add 1 to them. So 1/2 of 1 is 1/2 plus 1 is 1.5. That one right there. 1/2 of 3 is 1.5 plus 1 is 2.5. That's this guy right here. And then 1/2 of a third is a sixth, plus 1 is 1 1/6, or 7/6, which that's right above that line of 1. So you could actually do it over here just by manipulating the y values. This would manipulate the y's, this would manipulate the x's. So let's see what would happen. It's really easy if it's only shifts. I add 4 for the x, I subtract 5 for the y. So let's see what my transform points should be. 0 plus 4 is 4. 1 minus 5 is -4. That should be 5. Let's see, use a calculator if you need to. 3/2 minus 5 is -7/2. And then if I add 4 to -1, that's 3. I do 2/3 minus 5, that's -13/3, which is 4 1/3, -4 1/3. So this is what the points should be based on the arithmetic, right? You add 4 to the x, subtract 5 from the y. My asymptote is going to be at -5 on the y equals -5, excuse me. But here's what I'm going to do. I'm going to graph it. I'm going to plot my basic points. 0, 1, 1, 1.5, -1, 2/3. And then I'm going to take those points and I'm going to shift them. I'm going to go right 4, 1, 2, 3, 4. I'm going to go down 5. 1, 2, 3, 4, and 5 right there. Let's see if that works. I should have 4, -4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. I'm a little off, but yeah, pretty close. And yeah, it's 5. And let's see, -7/2. That's -3.5. -3.5. So it really should be right here. -13 1/3, or -13 thirds. That's -4 and a piece. -4 1/3. Well, so that worked. All right. So I'm gonna sketch it. And let's see what that is. Actually, it's probably too steep, huh? It should be a little less steep. Maybe like that. I don't know. I'm not great at drawing. I don't expect you to be great at drawing. Just do your best. Have your basic points and give me the right shape. It'll be good if you can do that. Now, if you need to draw the dots and move all the dots around, that's fine too. If you have a computer that you're willing to use Cammy with, you can easily manipulate it yourself. You hit that little select tool in the top right, or top left usually. That's the default. It's up here. And it has those concentric squares that'll let you select stuff and move it. So this might be actually easier to do on Cammy than on paper, because you can just literally shift it 4 units to the right and then down 5 units. Stretching, can't really do that. Domain has not changed. Range, well, that's definitely changed. It's -5 to infinity. Not inclusive. As x gets really big, y gets really big. As x gets really small, y gets really close to -5. My y-intercept, I'm not sure. It's going to be pretty close to -5, though. Let's see. It's going to be 3/2 to the 0 minus 4 power minus 5. Let's see what that is. 3/2 raised to the 0 minus 4 minus 5. That's -4.8. We're going to go to the 10th place. So -4.8. So 0, -4.8. Yeah, you could have written that fraction if you really, really wanted to. -389/81. Sure, why not? But no, just round to the 10th place because you can actually plot that. Yeah, it should be like right here. Asymptote y equals -5. Done. All right, last graphing problem. Let's see what's different here. Let's see, B is 4. Makes it a growth problem. Basic points. This guy's even further than one that we've dealt with before, so he's got to be really steep. All right, so what am I going to do with this thing? So start with reflections. Reflect over x-axis. Then I'm going to stretch it by 2 vertical. And I'm going to go right 2 units. So here's what I'm going to do this time. I'm going to do my dots first, and then my asymptote. Wait, no, where's my asymptote going to go? There's no vertical shift, is there? No vertical shift. Asymptote's on the x-axis. So that ain't moving. All right, so I'm going to plot my basic dots. And I'm going to transform them. So you got options here, people. You can figure out the coordinates. You can plot the dots and then manipulate them. You can plot the dots on camera and then move them around. Now you can't reflect or stretch them on camera really, but you could move them individually, I guess. But let's just do it. 0, 1. 1, 4. And -1, a fourth. So let's just think. We haven't looked at this one yet, so we don't know how steep it is. If I plug in 2 into just 4 to the x, that would be 16. So this guy's going to go off the grid even with 2, so that's really steep. Let's reflect over the x-axis, though. So if I do that, it's going to go there, that's going to go there, and that's going to go right there. Reflect it. Okay, now I stretch the y values by 2. Let's use this nice color here. So this is going to go to a half, negative half, sorry. It's going to go to -2. This is going to go to -8. Wow, really extreme here. And then I got to shift everything to the right 2 units. So let's go with this nice light blue. 1, 2. 1, 2. 1, 2. Again, with graphing mother functions, you probably want to go with some colored pencils or something. There's going to be a lot of stuff. There's dots all over the place. And if they're all in pencil color, it might be hard to keep track of what's what. And I'll just try and graph this. And it's going to be terrible. It's going to be really terrible. Yeah. But it should be something like this. Domain, that doesn't change. Range, what's the lowest value I've got? This time it's -infinity. I reflected it, right? It goes all the way up until 0. So as x gets really big, y gets really, really tiny. Okay. As x gets really, really tiny, y goes towards 0. Y-intercept, figure it out. Do that, that's -1/8, right? -1/8, yeah. Pretty freaking tiny. 0, -1/8. So this is way too tall. It should be practically touching already, but yeah, I can't draw that. Asymptote y equals 0, because we didn't have a vertical shift. We did not change where our asymptote was. All right, that's it, guys. That's graphing the mother function and transforming the mother function. Done. Next up, we're going to solve these mother functions. That's going to be another video. See ya.